Let's continue talking about variables. By now, we know how to name a variable. We know that we have to use some sort of name with identifiers where we should not use underscore for the variable name because those are reserved for internal variables for the system. Therefore, when we create variables, of course, one thing is the name, but another important thing is what is the value of the variable. So if the variable has the value of a whole number, positive or negative, that is an int. And if it's a fraction, that could be a float or a double. So we'll talk about floats and doubles in a few minutes. For now, we're going to start with the most basic variable, which is an int. And the way the variables are allocated is always from right to left. When you write on your notebook, it doesn't necessarily make any difference if you say 100 is equal to x. But in a code, in a programming language, this is very important. Variables are always assigned from right to left, meaning that the variable is always going to be on the left-hand side, and the value of the variable will be always on the right-hand side. Therefore, x equals 100. X could also be a string, or basically a string of characters, which each character is a letter or a number or an identifier. The difference is that strings are handled differently. So x equals 100 could be a string, and we'll see in a few slides an example. But the important thing is for the programmer to know if 100 is a string, then the operations that you do with the string are different than if 100 is a number. Another key point, if x is equal to 20 space minutes, this could be a string, but it could be further cast. You can cast this string into the int, which is 20, and the string, which is minutes. And you can get rid of the space or have minutes within the space. Again, the programmer decides what to do with the string. So this is very important because when you read a file, you read strings, you read characters. When you write a file, you need to write to the file using strings and characters. When you ask for input to the user, if you have to go to the ATM and you ask the user to type something, the numbers that you type would probably be inputted as strings. So strings are very important to understand as a concept, because then later you can use different operations to get numbers or to use the strings to concatenate to other strings. So in the example that we had before, where we said hello world, the string is this whole thing, hello world. This is our whole string, well, except for the semicolon, which is for end of line on C++. This hello world is the whole string. As we said before, the int represents whole numbers. It could be positive or negative. The way to allocate variables in memory is by, of course, using bytes. So as you know by now, 1 byte is equal to 8 bits. So when you have 8 bits, you will basically have this train of possible allocation space where you can put up to 256 configurations. And in RAM, this is temporarily allocated. In your hard disk, this is allocated indefinitely until you format your computer or until you erase the data or something like that. So you can dynamically change the value of your variable in the memory and be constant and never change the declaration. So if you start with a matrix called A, and this matrix is gonna be 1000 by 1000, don't, as a rule of thumb, later on, don't use A and then B equals to A and C equals to A and then have a bunch of matrices allocated in RAM, because that is gonna occupy a lot of space that you, later on will make you run your program, might cause to slow down your program. So an int has 4 bytes in memory, occupies 4 bytes of memory, or in other words, up to 224 characters. Okay, so this is the same as 32 bits. You always, as a rule of thumb, initialize the variable. So the variable that is going to be used later on, first, you initialize it so that the program knows that it's going to be used later on, and that is getting some room, is allocating some space in memory to make the program more efficient. And then later on, you can assign the value of the program that you need or you want. Cin and cout are standard functions in C++ to output and input data from the shell or the console. And this is an easy way to ask for input for the user. We'll see an example. By now, you can recognize that we're using the header for std input output. So this is going to be one standard library that we're going to use every time that create a C++ code. And every time that you want inputs and outputs to your terminal or your console, you're going to use input output stream. So let's run this code and then you'll be able to go line by line with me. So compile, no errors, run it. How old are you? How old are you is this line right here. Notice that is asking for how old are you, and then has the room for you to enter a number. Okay, so cout is console out, is printing a message, and then is jumping to the next line because we are concatenating to end of line. Okay, so this end of line is making the code jump to the next line. So this is where you enter your age, I don't know, 20 or 30, whatever is your age, or my age, 30. And then once you enter your age, that is allocated to or saved in a variable that I'm calling age. But this could be anything, could be X. In that case, we compile it again. Remember, any change you make, you need to recompile it, and it's saying, well, I don't know what age is. So you're saying error, age was not declared, and that is because we have an X now instead of an age. There's no error. And well, how old are you? 35. Okay, you are 35 years old. So here at this point, it's asking how old are you, we're inputting the age, which is the variable that you initialized before. So if, let's stop right here. If you didn't initialize x, it would say error. X was not declared. Okay, so let's go back to our age since it's more intuitive. That's another thing. Please name your variables with intuitive names. X could be anything, but in this particular case, we're asking for age. So let's name age. How old are you? 30. And is returning age console in. So this is a very important part also. Remember to add this whenever you're going to use cout and cin. The direction of the flow matters. So cout is outputting how old are you. Cin is taking whatever you input and saving it in age, which is an int. And then it's saying cout is going to print, okay, you are the variable. So it's saying, okay, you are, this is the variable that we just inputted, years old. End of line. Return 0 to make sure that we have no errors, and that's the code. So if you were to run it again, and instead of that you put 30, there will be an error. Why? Because we're saying that age is an int, and age is not taking int. So if you were to say age is string, age, and then you say 30, then you can say you are 30 years old. So see how the variable declaration makes the whole code work or not work. Back to the theory about memory. So whenever you have double or floating point, as we mentioned before, those are for decimals. So, well, I guess technically 0 to 9 are decimals because are a base of 10, but these are fractions. So details of the fraction are captured after the decimal point. Details need to be stored in memory, just assigned or unsigned. So as the same thing as before, this could be positive or negative. Now, interestingly, you can choose between double and float depending on how much size or how much room in memory you need. Double is much larger than float. So float is also 4 bytes, like an int, but double is 8 bytes. So it's double the memory that you would get, depending on what type of calculations you're doing. So if you're doing some solution of a mathematical equation, and you want to be pretty precise, pretty exact, perhaps you need to use double. So as we said before, the way you assign your variable to float or double is just by typing float, the value of my variable, and then initializing it. Same thing with double. You would have to initialize it with double instead of float. So for instance, if we were here to say that age is double, and then you say, well, there's a change, you need to compile it again, and let's go ahead and run it. What's your age? So 30. It works because this 30 is taking it as 30.0, right? So 0.0, you can initialize it as a double. So this is another example. If you say 30.5, you're 30 and a half, then you can output your 30 and a half years old. Okay, And it should work the same with float. This is a very big, actually we can use float instead of double because it's so easy, or so the variable is, we don't need a lot of precision for this particular example. So 30.5, it works fine. Again, double is for a lot of space, when you need more space in memory, when you need to be very precise about your solutions of your mathematical equations, for instance. So as we said before, there's the difference is the size in memory. So age is int, but salary per month could be a double. So it's going to be twice as much, or double the size in memory. There's another one which is long double, and this is very rare, but you'll see it every now and then for computer software, like software that has to solve mathematical equations of fluid motion, turbulence, etc. They'll use long double, and now it's 16 bytes. So this will be a bunch of numbers after a bunch of decimals after the point. So pi, for instance, pi 3.14, 15, etc. is saved as a long double for many mathematical softwares. So physically, how does memory save on your disk, on your solid state disk, or on your hard drive? Is by electromagnetic force, so, or electromagnetic field, I would say. So it's the combination of magnetic flux and magnetic force. So how does the computer save the data onto the hard disk? That is done by the combination of magnetizing force, which is H, and the flux density, which is B. So the flux density is nothing but the electromagnetic field, or sorry, just the magnetic field, not the electromagnetic field. Flux density, magnetic flux density is the magnetic field, phi, divided by an area of a geometry. So magnetic field can be up in the air, it could be through a material. Well, talking about the material, a magnetic field through a material where you take a cross section, the area of that cross section, and you measure the magnetic field across that area. That gives you the magnetic flux. Magnetic flux has units of Tesla and is plotted on this vertical axis of a very common plot called hysteresis. The x-axis is the magnetizing force, and the magnetizing force H is, picture a rim or a circle, well, a geometry made out of alloy or steel, and then a copper or some conducting material is wrapped around with n number of turns. The magnetizing force is the number of turns times the electric current through the conducting material divided by the thickness, or in this case, the length of the wire. The number of turns times the electric current divided by the length, that you probably remember from your electromagnetics class, that is going to create a field. And in this case, it's going to create something called the magnetizing force. So inside your computer, there's going to be a configuration that is going to be creating magnetizing force. And the relationship between the magnetizing force and the magnetic flux density through a magnetic material, can be plotted as such, where the hysteresis loop is because certain material, say barium titanate configurations, can be magnetized in such way that if you apply the magnetization force, a flux density is created. But if you remove the magnetizing force or apply the contrary current, or apply the current the opposite way, then the magnetization force is going to be inverse, creating an inverse magnetic flux density. So you can picture how by doing this operation with transistors, you can create positive flux density or negative flux density. And this is how you can save a zero. This is related to something called polarization. So based on this configuration, you can see how thresholds can be assigned to save a 0 with certain flux density or a 1 with certain threshold of magnetic flux density. In any programming language, there are the 4 basic operations that you could use without any external library. Those basic operations are adding, subtracting, multiplying, and dividing. In some programming languages, you have to be consistent when you combine types of variables. So, for instance, if you have a variable that is 3.0 and you want to add 4, so if you were to do this using C or C++, you could say x equals, or float x equals 3.0 and int y equals 4. When you do a summation of x plus y, so say you want to say print, for example, print x plus y. This will give you an error depending on the compiler, because one variable is a float and the other one is an int. Some compilers won't give you an error, and some advanced languages like Python, you don't even have to identify, you don't have to initialize the variable or declare the variable with a float or int or double or anything. You just say x equals 3 and y equals 4, because it's trying to avoid all this delicate issue with the variable types. But in C++, it's very important that you are consistent, and if you're going to end up subtracting numbers, make sure that the numbers are the same variable type. So you can subtract ints with ints and floats with floats. But if you end up needing to subtract a float and an int, you have to operate some type of casting to avoid errors. Another thing that I wanted to mention was binary operations, and this is going to be very short, just to make you aware of how computers compute stuff. So if you remember, when you have binary numbers, you would have, let's start with binary numbers, you would have something like, say, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 7, 2 to the 8. Okay, so this is 1, 2, 4, 8, 16, 32, 64, and 132. 128, I'm sorry. Okay, and actually we have, this is 1, 2, 3, 4, 5, 6, 7, 8. Yes, so this is actually not part of what I need, because we already have a byte, which is 1, 2, 3, 4, 5, 6, 7, 8 bits. Okay, so if you have, say, 0, 1, 0, 1, 0, 1, just to do something simple. It applies for all the 8 bits, but if you have a 0 here and nothing else, then this is a 0. If you have a 1, then this is a 1. But if you have, for instance, say we have this, an example, we have 0, 1, 0. So you're saying that this, where you should have a 1, you have a 0. And when you should have a 2, you have a 1. Where you should have a 4, you have a 0. And everything else obviously is going to be 0. So this is not even needed. The 1 and 0 is 2. Okay. Another example, if you have 1, 1, 1, 1, that means that is going to be 2 to the 0 plus 2 to the 1 plus 2 to the 2 plus 2 to the 3. So basically this is going to be 1 plus 2 plus 4 plus 8, or 3, 7, and 15. So this number is equal to 15. Okay. And obviously 1, 0, 0, 0, 0 is 16. So that's how you build your binary numbers. Now, to do operations with binary numbers, you do something like, say you have 1 and 1, then if you add them, you're going to have, of course, with binary numbers, you can only have a 1 or a 0. Therefore, 1 plus 1 is going to be 0 and carry over 1. Then you put a 1, therefore 1, 0, this is 2. If you have 1, 0, 1, 1, so what is 1, 0, 1, 1? Let's say 1, 0, 1, 1. So this is 8 plus 0 plus 2 plus 1, right? So this is 11. And then the other one is 1, 1, 1. So the next one is 1, 1, 1. That is 4 plus 1. Sorry, 4 plus 2 plus 1, which is equal to 7. So 1, 1, 1 is 2 to the 2 plus 2 to the 1 plus 2 to the 0, which is 4 plus 2 plus 1 equals 7. If you were to add this up, you're going to get 18. Okay, so if we do something similar, then we do 1 plus 1 is going to be a 0, carry over 1. 1 plus 1 is 0, plus 1 is 1, but you carry over 1. Then 1 plus 0 is 1, plus, of course, you're following down here, right? So 1 plus 1 is 0, follow 1. 1 plus 1 is 0, plus 1 is 1, put 1, carry over 1. 1 plus 0 is 1, plus 1 is 0, carry over 1. 1 plus 1 is 0, carry over 1, but put a 0 and then drop the 1. Okay, so this is the same as 16 plus 0 plus 0 plus 2 plus 0. 16 plus 2 is 18. So this number, or 10010, so 10010, 10010 is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. So 2 to the 4 is 16, plus 0, plus 0, plus 2, plus 0. This is equal to 18. Okay, so it's the same thing. Subtraction is exactly the same, except for now, when you have a 2, and you subtract 1, then you have a 1. So for instance, in this case, it's going to be whenever there's a 0, we're going to have to borrow. Okay, so 1, 0, which is 2, and 1, which is 1. 2 minus 1 should be 1. So 0 minus 1 can't do it, so we borrow 1. So in that case, it's going to be 2 minus 1 equals 1. Okay, same here. So this is going to be 4, 0, 0, and 1, 0, 0 is 2. So 4 minus 2 should give us 2. Okay, so 0 minus 0, not possible. So we're going to do 0, 0 minus 1, 0 is not possible. Therefore, what we're going to do is we're going to borrow 1. This one is going to turn to a 0, and now here we're going to have 1, 0, or 2. Let's put a 2 for now here, so it's easier to visualize. So instead of this 0 here, we're going to have a 2, or a 1, 0. So 2 minus 0 minus 1 is 1, right? 2 minus 1 is 1. And 0 minus 0 is 0. Excellent. So we have a 2. Let's go over this one. 1, 0, 0, which is 4, minus 1 is equal to 3. So that's what we get. How is this done? 0 minus 1 is not possible. 0, 0 minus 1 still not possible. So this one is, we're going to borrow from this one. So up here, we're going to write 2. So up here, I'm going to write a 2 for that. So instead of this 0, we're going to have a 2. From that 2, we're going to borrow another one. So now we're going to have a 1. So this one is going to be one that we're going to drop. And then instead of this, we're going to have 2. Okay, so now this is not 1 or 2 anymore. This is a 1. And then from these 2, we're going to subtract 1. So we get 1. So is 1, 1. Okay, so it's a little complicated. I think it's more complicated than addition, but still, if you borrow and you realize that when you borrow you have a 1, 0 or a 2, then you should be able to complete your subtraction. Then for multiplication is something similar to regular multiplication, is let's say the same thing. So 1 times 1 is 1, 1 times 0 is 0, 1 times 0 is 0, 1 times 1 times 1 is 1. So first line is the same. 0, we're going to put a 0 down because we move one place. 0 times the whole thing is going to be 0 all over the place. And we're moving on down the 1, so we're going to put a 0, and 1 times everything. Right? So this is subtraction. Subtraction is much easier. And it's going to be 1 plus 0 is 1. 0, 0, 0 is 0. 0, 0, 1 is 1. 1, 0, 0 is 1. 0, 0 is 0, and 1 is 1. Excellent. So what is this? This is 1. This is the place for 2, but we have a 0. This is 4. This is 8. And this is 16. So 16 plus 8 is 24, plus 8 is 28, plus 1 equals 29. Okay, 29. Is that what I get? Is 1, 0, 4, 8, 16. 1, 0, 1, 1, 0, 1. So we have 1, 0, 1, 1, 0, 1. And this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. Oh, okay, sorry. 1, 0, 1, 2, 3, 4, 5. Yes. So my bad. I have to do this now, which this is 1 right here. 1. I have a 0 here. 4, 8, 16, but we have a 0 here. 32. Plus equals 32 plus 8 is 40, 44, 45. All right, that makes sense. 45. Yes, because 29 is a prime number. I wouldn't be able to get that multiplying. And what is this? This is 1001. So if we have 1001, we're going to have 1 plus 0, which is at 2, 0 at 4, and 8. So this is 9. And the next one is 101. So in 101. 101. So this is 1 plus 0, and then this is 4. This is so 9 times 5 equals 45. There you go. Excellent. So multiplication and addition is simple enough. Subtraction is a little confusing, but it's pretty straightforward if you remember that when you borrow, you just have to write a 1 0 on top, which is a 2. So when we talked about variables, we talked about int, we talked about float, or I'm going to use this again. We talked about int, we talked about float, we talked about double, and we said that these were for numbers. There's something else. We need to talk about strings. Strings and char. Char from character, and strings is strings of symbols. So when you write, when you say hello, this is a string that has 4 characters. This is character number 1, character number 2, character number 3, 4. Sorry, it has 5 characters. 5 distinct characters. I'm confusing myself. Has 4 distinct characters, but 5 in total. So the 5 characters are H, E, L, L, O, but the only distinct ones are H, E, L, O. Meaning that the string, the size of the string is equal to 5, and the components of the string are 4 different characters. Okay, so that's the difference between string and char. If we were to do an example, so let's create an example. So I'm going to include the header for the library that we're going to be using from the C header. We have the main function. We're going to have char. It's going to be a open array. We'll talk about that later. So this is to say allocate memory, enough space in memory to allocate this string, which is string. Has 1, 2, 3, 4, 5, 6 characters. This is 1, 2, 3, 4, 5, 6 characters. We're going to use a printf, and we're going to say s, which is the string, is a %s, and we're going to plot string. So what does this mean? This is basically saying that print s is %s is for the compiler to understand that we want to print a string. So if you remember, I'm going to write down here, %s is used for strings, is used for print strings. %d is to print int. %c is to print characters. And %f is to print float. So %d is decimal, but I said it's because it's 0 to 9 is decimal base. And these are the things that we use for printing when we want to print a screen. So now let's run this case, and let's go ahead and run, and let's save it as week 1 executables, and we're gonna save it as, so notice that you can save it as C++, C, CP, etc. So you can also save it as C. Okay, so even though we're gonna be learning C++, as we mentioned, C++ is built on top of C. So this header and this code is basic C. It doesn't have any advanced features that require C++. So we can save this as, put a name, print string .c. Well, don't confuse ourselves. Just press enter. Oh yes, we can save it as .c. Okay, good. Print string .c. Save. Include std. Okay. .h. Okay, so this is an error, a compilation error, because this library is for C++, but we're not going to be using C++. So let's comment this out. I need to correct myself. We are going to use C++ after this first week, but right now I'm going to show you that this basic code is using C++, sorry, is using C, and later we're gonna use C++, but I want you to see the difference between C and C++. So one difference is the header files. This is what you will run using C, is .h header file, and S is a string. Okay, so now let's run this with C++. New file. In that case, we're gonna comment this out. Remember that the 2/ mean it's a comment. And then we're gonna save this as C++ string print, and then we're gonna run it. No error. Run it. S is a string, and if I were to do this and run it, then I don't have an error. So C++ can run C code, most of it, and compilers will accept most of it, but C will not take C++. And remember that is because C++ is built on top of C. Okay, so if you run it, you'll see that it says S, this is that S, it's right here, string. And this string is because it's taking %s and is linking it to string. This S is right here, right? This is S. the forward slash, the backward slash, this \n only means jump line, right? So this space right here, right? In other words, if I were to copy this and print again, compile, run, print s, okay? If I were to remove that jump line, then they were gonna print next to each other, right here. Another example would be running the character. So let's go to the example on your PowerPoint. So let's copy this and go to your dev++, paste, and let's save this as a different file. So it's going to be a C++, say string print example2. And what we need to do is compile with no errors and run it. All right, so let's see what's going on here. Include the library. That's always something that you need to include because we're going to be using printf. If you were to remove this, you try to compile, it's going to say printf, it doesn't know what to do. So that's why you need it. All right, so let's go ahead and see what's going on. So in the main file, this is the main function, I'm sorry, this is where you're going to do your code. So we're going to create a string of characters with dynamic or enough space to save our string here. So just by doing this, you can pretty much save a string any size you want. You just allocate it in memory, in RAM. And then we're going to see this later, but I'm going to use a for loop to loop over the string. So don't worry so much about line 6 right now. We're going to go over it later. I just want you to know that you can print a character with %c. So we're going to be looping over the array, and as long as the array has a position that is not 0, in other words, that it has a letter, then do another iteration. Okay, so I'm gonna have this posted for you to play with it, but later on we're gonna talk about loops. For now, I just want you to have a sense of how to print characters and how to print strings. Let's go ahead over this example. So copy. I'm gonna go to dev++, close all the applications, all the executables, new, and I paste. All right, so in this case, we're gonna have a new line, which is namespace standard. It's because we're gonna ask for information for the user to input. So let's go ahead and save, and I'll show you line by line. So ask user favorite food. Please do not save your file with spaces. Okay, you can put a back underscore or whatever you want, but do not save it with space in between the words. All right, no errors. Let's run it. Excellent. So please enter your name, but before that, let's go over the code. Line 1 and line 2 are headers and initialization of the standard library. We go into the main function. You know that always a C++ code or C code also has a main function with a return 0, saying return successful. Then we're going to initialize a name, which is going to be a string, and a favorite food, which is going to be a string. Why is not a char or a character? Because it's a bunch of characters in a string. So the string is going to be saved as name and fast food. It could be as long as your name is or as short as your name is. Just by doing this, the computer will allocate memory for the string. So console out is going to say, please enter your name. and then it's going to input an end of line. So it's going to print out end of line, which is this, and then it's going to wait for the user to console in or input a name. So Carlos. Therefore, it's saying console out hello, comma, the name of the variable, the string Carlos, comma, nice to see you. What is your favorite food? In jump line. Or I could have also done end of line. This jump line is similar to this end of line. The difference is this is within the quotation mark, and this one is outside. What is your favorite food? Okay, so it's waiting for another input. So let's say pizza, for instance. You can never go wrong with pizza. So it says, great, pizza, favorite food is a string, is one of my favorite foods too. Excellent. Return 0. So return value 0 is successful. Enter. So go ahead and study this code because it's very simple and it gives you a flavor of C++ to input and output information through the console. There's another example that I want to run, which is, let's go to my Def++, and this is print a number, or print two numbers. Okay, so let's run it and see what it does. Okay, so int x equals 42. So obviously we could also do, which is much more efficient, x equals 42. We're going to initialize it and declare it at the same time. So it's going to say printf x is %decimal / to print x. So up until here it's going to show in console. Up until here is going to print what you have as your variable and jump line. And x is but my new x is 73. All right, let's run this code and see what it is. X is 42, but my new x is 73. Right? So what happens if I say string? The compiler will say x is, doesn't know what x is. And furthermore, if you say character, x is a character. Right? So be careful with your variable. You print your variable that has to match your same variable, okay? Excellent. So x is 42, but my new x is 73. How to use variables in my code? By now, you realize that there's an order. So if you initialize your variable as price, 4.5 or 450, and then quantity equals 0, if you want to charge your price and your quantity, but your quantity is 0, then you're going to have an error. What you need to do is initialize your quantity first and then ask the user or whoever for the value of the quantity, or reassign a value for your quantity. So this is not about the quantity of the price. The point here is that when you use a variable, make sure that it's following the flow that you designed the variable to be part of. So the variable needs to be initialized and assigned before it's used. Then make sure that you don't use it until it's initialized and declared. Some common errors with variables are, as we mentioned before, that an int is going to be defined as a number, but later on you're going to use an int and multiply or add or subtract by a floater. If you have to do that, then you need to cast your variable. And it's simply by calling the static cast function. In that case, you can definitely be able to implement your code with different data types or variable types. And this is how you use it. You cout or fprintf static cast int, and then the operation that you need to do. Some useful operations are ceil or the ceiling. If you have 4.9999, you can approximate to 5. And floor, if you have 4.999, you can approximate to 4. So floor and ceil are some interesting functions that are part of C and C++. So let's go ahead and run this example. So let's run it and see what it does. Enter the quantity you wish to order. So I'm going to order 3 parts. The tax is charged as 0.54. The total is 1404. Okay, so let's look at this. We have that we have to use your namespace and your include iostream, because now I'm going to be using cout and cin. So in that particular case, we have to use the namespace. Okay, so if a variable is declared outside of the main function, it's called a global variable. So this is a global variable. And what it means is that it's going to be used everywhere with this value, and it will never change. So for instance, that was a pretty low tax. Let's say is 7.4%. Okay, so we're gonna say declare variables. These are not global variables because they're inside the main function. So string is name, float price is 4.5. Notice that I'm not asking for price, I'm defining it here. And your price could be 14.5. It doesn't. This is where you design your code. The initial quantity is going to be 0, so it's initialized at 0. And your float for charging is 0 because it's going to be computed later. And the tax charge is 0 because it is also going to be computed later. Even though tax rate is defined, we're going to use the tax charge later. So we're going to get the input from the user. The question is enter the quantity with a cout. And then we're going to use a console int for quantity. And remember, the quantity is an int. So if you were to run this code again, and you put 4.5, then it still works. And then I'm going to change. Okay, so I'm going to change with int for a float. And to make sure that my compiler doesn't have errors. Okay, so quantity, then the charge of what I'm going to charge is going to be price times quantity. Okay, and the tax rate is the tax charge is charge times tax rate. Excellent. Cout is the tax charged is, and then charge is charge plus tax charge, right? So this part is basically the price times the quantity. If I'm buying 5 tortillas, then each tortilla is 50 cents or 20 cents, whatever. Then that's what my total. This is basically my total. And then the charge is my total times what is the tax, right? So at the end, I'm going to add that to my total. Cout is going to be outputting my computation of what is my tax. And then at the end, I'm going to be computing my total with my total plus tax rate. So a cool thing that makes elegant C++ is that I can do this plus equal. So what I have as my total is going to be updated to the value that it had plus what I'm going to call right now tax charge, right? So what I had before was charge plus tax charge, and this could also be computed like this. And then at the end, I'm just going to be printing that. Okay, so if I run it, enter the quantity 3, the total charge is 0.54, your total charge is, oh, I need to compile it again. So remember, when you make changes, you need to recompile it. Excellent. So 321, wow, 365.4. Oof, that's a lot. Is this making sense? The tax is 7.4, the price is 14. Let's run it again. So I want just one. Why is this so high? Charged is 107.3. So price times quantity. Quantity is 1. Price times quantity should give me, let's see what's going on here. Print F. So I'm going to turn this into a float. Yes, it is float. So charge equals percent F and charge. And then remember to add the semicolon. 1. Charge is 14.5. Okay, that makes sense. Then charge times tax rate. Oh, okay, my bad. I know why this is going on. It's because 7.4%. So is this divided by 100? Yeah, that's why before it was 0.4. It was 4%. My bad. All right, 1. Yes, there you go. Now it makes sense. Perfect. So hopefully that helps to clarify things. So I'm going to be uploading this file instead.